All right, this is the August 17th, 2017 recording for Kubernetes SIG scaling. All right, what I'd like to do is share the presentation that I'm proposing to give at the community update. Hang on a moment. You guys seeing that? All right, good.
Yeah, looks good here.
All right, super. So our habit here is to try to give the update at the SIG meeting, get some feedback, and then have a bit of chance to update it based on any feedback before delivering the final at the community meeting. So that's the purpose here. I'll go through this fairly quickly. This is repeat from last time. That should be completely non-controversial. I don't want to, I never want to, since I'm representing the SIG in the update, I never want to represent things that people are disagreeing with. The first bullet, I think, is non-controversial, but I am going to represent that that the tone has been shifting from sort of building bigger and bigger clusters to stability on 5,000 node clusters. And I'm going to ask the question about whether stretching beyond 5,000, there's an urgent need to do so.
I think what people might be interested in too, as well, is the idea of density of services and everything else. Because right now we could have that many nodes, but if we had it densely packed, it would implode still.
So specifically, I think I cover that in the rest of it, the rest of the presentation. Maybe we should come back and see whether, well, that really is the how do we ensure big clusters are stable with varying loads at the 5,000 node level question, right?
Varying loads and densities.
Loads and densities, okay. Okay, how's that?
Thumbs up.
Great.
So on that front, one question is like, if you're talking about the size of the cluster versus the entire fleet, like which includes multiple clusters, or are we just talking about a single cluster? When we say 5K,
we're talking about 5,000 nodes in a single cluster.
Okay. So my problem is that we want to have like slightly larger footprint across the board for all these things. So, for example, our availability zones have close to 20K machines. So, ideally we want like some features so that all this 20K can be managed, uniformly. But that might mean using federation. So, I'm not sure if that is the purview of this.
There's well-established documents that we have that having a single large X thousand in the tens of thousands node clusters sort of violates principles of failure domains. And federation is a potential escape hatch, but it comes with its own complexities. Like sometimes people just do multi-cluster approach too for evaluating dev stage and prod. There's many patterns that exist that give you an escape hatch versus having a single large environment.
Yeah, I'm not denying that that's exactly what we are also going to do. But the question is like, would that come under the purview of like, that number? What is the largest number of clusters which a federation can handle?
I'll add a clarifying note here. It's a good question, right? The 5,000 node target here is a single cluster. We haven't yet really extended our purview to 20,000 node federated cluster at 5,000 nodes each or something like that.
Do you happen to know if these docs discussing sort of motivations for why you might not want large clusters are in the SIG scalability directory, or are they buried somewhere in like the design proposals directory?
I don't know where they live anymore because they've shuffled the docs around so many times. But Quentin and Wojtek originally had the document which outlined why they were going to a specific size and what the primary goals and drivers were. And
Okay,
the cap was at 10,000 originally.
Okay. I think that might be the goals.md doc in SIG scalability, which we call out shortly.
So I made two edits to the slide. One was to just clarify bigger single clusters, and then just note that there's kind of an ongoing discussion. Let's call it not a debate. Discussion about very large installations and a federated strategy.
I don't know. I have very colorful opinions with regards to federation and the ideas therein. But you might just want to say multi-cluster strategy.
Multi-cluster. All right.
And you might want to put like, federation in quotes behind it. I think, my personal take on federation is that you're grouping failure domains, and like when we wrote up our blog post on it, we talked internally for a long time about it, and there's actually a 3-part blog post that Joe and Craig wrote up regarding it, but it conflates failure domains. So
very large are let's see, can be driven by failure domain considerations, not number of nodes per cluster.
May I also ask the name of the blog?
Up to you. Put the blog post in the channel, in the chat.
Okay. I think the color here is that things other than pure scalability of the control plane or node networking or something starts to drive the cluster designs at the scale. Or it can. If you're not doing overnight HPC loads or something, right?
Yeah, it's the wrong tool if you're doing super fast elastic HPC. Right? This is a service orchestration engine. It's a minivan for microservices, is the souped up minivan, as Bob would call it. Microservices.
All right. Do you think I've covered it here sufficiently for the community update to give the right flavor? All right, good. So I'm not intending, I mean, it's a fairly short update. I'm not intending to, are you guys seeing the speaker notes or just the slides?
Speaker notes also.
Okay, very good. Aaron actually typed up some very helpful kind of comments here. I really wasn't, it's a fairly short update. I really wasn't planning on covering all this in detail, but just to give the wider community some exposure to where the docs are, what they do. I do want to do a quick call out for folks that are interested in the provider coverage beyond the ones that we have. This seems like a good call to make sure they know that we love their input. So I'll cover this briefly. I'm going to mention event refactoring. Wish Merrick were here. And I think the only piece of this I'm really concerned about whether I'm representing properly is the 4th bullet, which is the sort of at least 2 releases of work with kind of a baseline into 1.8 and not really helping substantially until 1.9.
I just call it a work in progress because I don't know. I never know when any feature is going to land anymore.
Right. Well, I'm saying at least. I think we can say the first batch of work is going into 1.8 though, right?
I don't know. I see PRs, but I don't know if it's going to go into 1.8. If it goes into 1.8, it'll be not enabled.
Right. Well, that's what I was trying to say here. Won't affect.
But I would get, concise feedback from Merrick.
Yeah, shoot. I'm not sure I'm going to get that. Let me see if I can catch him online, and I'll dial this back to work in progress, with maybe parts of it starting to land in 1.8. Okay, I'll follow up. I'll fix this one. I'll fix this one later. Work in progress. Okay. Hang on. Sorry for making people watch me type, but there we go. There, that's sufficiently uncommittal. Short of getting some additional feedback from those guys. And so this is the paging API update. Just to let people know this is going on for these kind of like large scaling parameters bits. Pointer to that issue here. I got the 1.819, 110 bits straight from the feature repo. I pinged Clayton just a few minutes ago just to make sure he knew I was going to say this. So I think that one's probably okay. Cluster results sharing. I looked at the last update I did, and this was there too. So I think this is, Tim, this is probably mostly for you to make sure you're comfortable with this update in terms of our interest in the SIG for using Sonobui in some form to capture and share results.
Looks good to me.
All right. And then what I'm planning to do is introduce Aaron as having done some good work, constantly helping us keep the SIG testing and SIG scalability glued together.
Yo, hey, so this isn't something I can take a ton of credit for. I just happen to be aware of it because I'm part of SIG testing. So I think Shyam's been pushing this pretty hard. So one of the big things we noticed during the 1.7 release was that the scalability testing wasn't really passing, and we didn't notice this until late in the release cycle. So we put together a proposal, or Shyam and I think Merrick to some extent, we put together a proposal to make sure that full scale, like actual real testing with real nodes, was done continuously throughout development during this release cycle. So not just KubeMark and not just 100 nodes, but more at the 2,000 or 5,000 node level. So the initial proposal was to do this on some sort of like every other week schedule. That doesn't play so nicely with cron. So the schedule that we've actually ended up with today is we run 5,000 node GCE runs on Monday, Wednesday, Friday, 5,000 node GCE correctness runs. So this is basically making sure that the Monday, Wednesday, Friday runs are performance oriented. Throw the density test at it, make sure it meets those two big round SLOs that we've defined thus far. We'd like to get to the point where it passes sort of more refined SLOs, but this is state of today. The correctness tests make sure that all of the other tests still pass at the 5,000 node level. And then Saturday and Sunday, we also make sure we run 2K variants of both performance and correctness across GCE and GKE. We would like to get to the point where both GCE and GKE are considered blocking. Where we're at today is it's just the GCE variants that are blocking. Next slide. So the way this is implemented today, you may have heard me talk about things like Prow before. Jenkins is still involved in running tests for some things today, and this includes the scalability tests. So we use Jenkins cron trigger in order to make sure that the jobs are triggered according to the schedule I just laid out. And then we're using this script called Bootstrap in the test info repo. It's basically the script that if you run that locally, you would do all of the exact same setup and configuration and layering of stuff that would actually happen the same way we run tests for the project. So if you look at any of those end files there, you'll see the exact configuration down to the size of disk and size of nodes and QPS tunables that have had to been adjusted in order for the clusters to meet the SLOs at those sizes. Next slide. And we can maybe click through some of these links. I don't know. Basically, I just want to call out that SIG scalability is being a good SIG, and we have our own dashboard today. It's called SIG scalability. It's one of these fancy tab group things where we actually have just the density tests out of the GCE test. And then, yeah, maybe you can just open link. Cool. So you can see there's sort of all the tests that SIG scalability cares about are on that second row there. And then the top row calls out Google GCE scale and Google GKE scale. Those are the larger scale tests with the 2,000 and 5,000 nodes that I was just talking about. So you can see if there are problems with the tests that this SIG cares about, we can see that. And the other thing that I wanted to call out, again, I've mentioned that the GCE tests are blocking. If you go back to the slide and look at the release master blocking dashboard there, you can see I have two links to the GCE scale correctness and scale performance jobs. Those are the 5,000 nodes jobs, and those are part of the list of jobs that are considered release blocking. So the tool that's in charge of cutting builds for Kubernetes actually looks at all of the jobs in that release master blocking dashboard. So the same configuration that drives test grid is the same configuration that drives Anago. I always forget how to pronounce this tool, for those of you who are familiar with Anago. And so if this is red, which it is, we can't cut an alpha or a beta or a release. Okay, next slide. Something cool that we sort of discovered along the way is collecting all the logs from all the nodes when you're at 2,000 or 5,000 node scale takes a long time. So the way that it used to be done was basically SSHing through Jenkins to copy the logs off from each node. I think it was either in serial or parallel, but basically Jenkins was the one going out and getting the logs. We've now shifted to using this tool called Log Exporter. It's linked in the slides here. You don't have to follow through, but for people who want to look through the slides afterwards, it's a Kubernetes project. And basically the nodes are now responsible for pushing their own logs up to GCS. And then all we do at the Jenkins level is watch to make sure that all those logs land. And then we can, well, the logs are already there at GCS. So what this means at the 5,000 node level is instead of spending over 4 hours to collect logs, we now just spend less than 20 minutes. And at the 100 node level, it's productive as well. It's taken us down from 10 minutes to 2 minutes. This is now enabled across all the scalability jobs, and we think it works so well that it might be worth pushing to all of the testing jobs, period. In the failure mode where a node fails to come up or doesn't come up completely enough to push its logs to GCS, we can still fall back to SSHing to the node to collect what is there for forensic purposes.
It seems weird. Like, what's the biggest, I mean, the time frame seems weird. What's the biggest lag? Is it everybody writing the GCS buckets in the pipeline? Because we did, you know, if you're writing to a single node who actually is running to a spinning disk before you tar it up to push it off to some bucket, is it all of these nodes trying to hit the same location via some web traffic thingy?
Are you saying the final time of 20 minutes is still too slow for 5,000 nodes?
Yes. I'm saying that that's kind of egregious because, like, if they're all doing it in parallel, it should take, like, order very little time. Depends upon how much log data there is, right?
I would encourage you to go check out the linked pull requests there and maybe follow up with Sham. Because it's, you know, it's at least an order of magnitude better than it used to be. Like I said, the old solution basically involved copying all the logs off of those nodes onto a single location and then pushing from that location up to GCS. I don't know why we were doing it that way.
Yeah, but this is very internal to Google, which is why I don't like it too. But anyway, it's a separate thing.
Yeah, it does seem kind of weird. You'd expect, based on that description, for it to drop a lot more. Just like
Sure.
better.
Yeah, yeah, if you're interested in digging into this, those are the places to get to dig into it for sure. Because if that's a blocker to enabling this across all jobs, we would want to look at that. I think I personally was more concerned about the correctness angle. That, okay, if we're leaning on GCS and we're leaning on the nodes to do it themselves, what if the nodes aren't functional, right? If a node doesn't get far enough to actually be running the kubelet process and then schedule a container that's responsible for shipping the logs up to GCS, I'm going to have no logs, and that's really impossible to debug from a forensics perspective. If I have tests that fail because the cluster failed to come up, I want logs that tell me at least how far that it did get. Anyway.
Well, hopefully, no one will poke at that one during the community meeting.
Oh, Tim's a pokey guy.
Oh, he wouldn't troll you during the meeting like that.
And
I'll troll you here, but I won't troll you there. But this isn't even yours. This is a Googleism, right? For Google testing, and they developed what kind of, I'm going to go on a little rant here because I got the time.
Okay.
They've developed something that's very useful, but only useful in the context of the testing infrastructure, along with using Google stuff, right? This is a general purpose problem that the community has, and we've developed something that lives outside of it that does something similar. But unifying these tooling and tool chain type of problems so that they are generally useful to other people is a thing that we should be solving, versus like, we need it for test infra or the test chain tool chain, so we'll build it here, and now it's so entrenched into test infra. Disentangling it and getting out this general composable piece to be generally useful to the broader ecosystem is a non-tenable thing, right?
Right.
On a related topic, one of the things that jumps out on this slide is there is no 5K tests on AWS, for example, that are blocking.
Nope, there are not.
So that
Exactly, and you couldn't use the log tester for it, right? So
right.
Well, so I bring it back to the funded mandate example. So Tim, you might be right that this is a common problem that everybody has, but I'm not sure that anybody actually dove in and fixed it in a way that it works for everybody. I have to go look at the commit logs, right? But I think this was just like a tool that was needed to reduce the amount of time it took to solve this problem at scale. Otherwise, it wasn't painful enough for people to work on it. I'm sure it would be very welcome if the log exporter code base was improved to write not just to GCS, but to any old object storage or bucket, right? So, like, if this should have been more appropriately planned as a feature or a effort, I'm trying to dovetail into Bob's final slide here. Like, what would have been the forum to raise this, to write it up as a design proposal, to get input from people, and then to finally implement it. I think that somebody probably opted to just scratch the itch that they had at the time. But I don't think that would detract or in any way dissuade from people who want to make this work more.
Well,
and the same thing from the AWS perspective, like if we want AWS tests to be blocking, somebody who can stand up a 5,000 node cluster in AWS should probably be dedicating the resources to make that work on a continuous and reliable basis. Google has dedicated one person, Sham, to making it work on a 2K and 5K node basis, probably with some assistance from Wojtek and Merrick, right? So I don't know if that would be somebody from SIG AWS or if that would be the people behind COPS, since COPS seems to be the officially tested path for AWS, or whether it would be potentially AWS themselves if they'd like to volunteer that. We would absolutely welcome it.
I think calling out AWS, seeing how they joined the Cloud Computing Foundation, seems a reasonable thing to do.
I think I'm certainly inclined to take another round of I'll say evangelism with both the Azure folks and AWS to see if we can't get some support from them on this. So I'll go talk to Gabe and Brendan and say, hey, what does it really take for you guys to help do these 5K node tests on Azure? And I can do the same thing with Deepak and those guys over at ECS. They really ought to, right? I mean, it'd be a good thing.
Yeah, totally. So like I said, just to your point, Tim, if any of this is coming across or being presented in a way where it looks like we would not welcome the effort, we have to work on that. But I believe any and all are very welcome to contribute. And I don't just mean this as pull requests welcome. I mean, seriously, what about the on-ramp is preventing people from getting onto the ramp? How can we help?
Yeah, I think we need folks who would help own it for the different providers and to validate these pieces, to abstract it away, right? Like, I don't know of an owner other than reaching out to the separate cloud SIGs, but there isn't a representative from the separate cloud SIG. This might be a call out location, be like, it would be nice if those who are providers for different, or just providers in general, I guess, would also do similar types of validation or help support this effort.
I'll definitely do
a call to arms type of thing.
Yeah, I'll definitely do the call outs during the meeting, but I also want to follow up separately from the meeting because I don't know who's showing up and not. I mean, the Azure folks are clearly going to be on the call, but I don't know. The AWS folks seem to kind of hop in and out. So. All right. Anything missing?
I don't think there's many other updates for this cycle, really.
Great. Okay. Well, we're out of time. I think this is mission accomplished for today. I know, Tim, you wanted to have some other discussion, but I don't think we have quorum for it. So
I don't really have another discussion on anything else, really.
Okay. Anyone else? Anyone? Okay. Well, we'll see everyone at the community meeting.
Thanks, all.
Have a great day.